All right, guys, Mr. Jenkins back here with the rest of your 4-4 video, just example 4, which deals with your nonlinear function rules, graphing those. And I would just say that you're not going to really be able to do those without a table, right? So you're not going to really, if you're using slope and y-intercept to graph the linear stuff, that's great. But you're going to have to kind of change your approach on this one, okay? So one is what we call an absolute value function, and the other one here is just an exponential function. All right, so actually this would be called a cubic function, so sorry about that. So just a quick review before we get into A and the math of it. What is the absolute value of a number? And just remember, basically, that's how far a number is from 0. But for our purposes, why that matters is that a number can't be negative, really. All right. So in other words, like the absolute value of 2 is equal to the absolute value of -2, and both of those are equal to 2. All right. So the absolute value of -10 is 10. The absolute value of 20 is 20. The absolute value of -500 is 500, right? So you guys have heard that before, but these are things we forget because it's not something that comes up a whole lot. Looking at A, one thing we know about it right off the bat is that it's going to be a discrete function because they give me a domain. So that helps me to set up my table. Let this catch up real quick. So we have an XY table. And then I'm going to do my rule in the middle. So it's absolute value of X, take away 4. All right, so we know we want to sub in for X -4, -2, 0, 2, and 4. And we're going to get whatever we get. All right, so the absolute value, I know that's hard to see, but it says the absolute value of X. So the absolute value of -4 is 4. So this is really just equal to 4 minus 4 is 0. So one of my points is -4, 0. 1, 2, 3, 4. -4, 0 is right there. Next one, take the absolute value of -2. That's 2. So next one is 2 minus 4, which would be -2. So -2 goes to -2, which is right there on our graph. I'm going to give it a second to catch up. All right, there we go. And now we're off and running again. The absolute value of 0 is 0. So this is 0 minus 4 would be -4. So 0 goes to -4. We can see a pattern. And if you just follow the pattern blindly, you would think it's going to be linear, right? But watch what happens when we sub in 2. So absolute value of 2 is 2. 2 take away 4 is -2. Okay, so it looks like 2 is going to go to -6, right? But actually, it says when we do the math, 2 goes to -2. All right, so now it kind of changes directions. Next one, take the absolute value of 4 is 4 minus 4 is 0. So +4 goes to 0. So anytime you have, so we see that kind of V shape. Anytime you have an absolute value function, you're going to see a V shape. And remember here that because this is discrete, and I know it's discrete because they give me a domain, I do not connect the dots, all right? I leave it just as individual points. Okay, so that's that one. If you get an absolute value function on MathXL, this will be a good help on how you can graph that. All right, so the one after that has no given domain. Come on back. It has no given domain, so we know that this is going to be continuous. Continuous. Sorry. There it is. Get a little impatient with this thing. All right, so continuous, we're basically going to approach it the same way. We're going to have x, and we can sub in anything we want for x, and then that will go to its output, which we can call y. All right, so my rule here is 2 times x cubed. So for this one, I'm going to use my calculator, okay? So how do we know what to sub in? That's a question I always get, all right? So I would say if you get an x cubed or an x squared, this is a good set of numbers to plug in. So I would sub in -2, -1, 0, 1, and 2. Which will pop up, right? So not that you should have known that before going in, but those are good numbers to sub in. So we're going to sub in -2, -1, 0, +1, and +2. And we're going to let our calculator help us so we don't make any mistakes. All right, so I'm going to go 2 times, and I'm going to use parentheses here. It's important to use parentheses. -2, close parentheses, cubed. All right, how do I type that in? That's going to be caret key 3. On your calculator, it may not look like that. It may just look like caret key 3, but that's what you want. And then we hit enter. So it looks like 2 goes to, -2 goes to -16. All right, so this only goes down to -12, so that's going to go off my graph just a little bit there. Try to put it in the right spot. We could also scale our graph if we needed to. We could count by 2s. Give it a second to catch up here. Oh, sorry for all the lag time here, guys. Come on back up now. There we go. All right, there we go, perfect. All right, so -2 goes to -16. So remember, that's -212. So I'm just going to go just off my graph, just kind of guess where it would be. It'd be in that area. Next one, we're going to sub in -1. So 2 times -1 cubed is what? Let's see. 2 parentheses, -1, caret key 3, that's cubed, and then we hit enter. So that's going to be -2. So -1 goes to -2. -1 goes to -2. All right, so since this is not working so well, I'm just going to do the math for you on the next two, but just take note that anytime you're doing, cubic functions, or if this were a 2, anytime you have an exponent after your variable, you want to plug in parentheses. That's really important. But just to wrap this up so you have time to work and hopefully get this done, I'll just do the math without the calculator on these next couple. So 2 times 0 cubed, that's just 2 times 0 is 0. So 0 goes to 0. Next one, 2 times 1 cubed, that's just 2 times 1. So 1 goes to 2. And then you could probably guess what's going to happen when I do 2 times 2 cubed. If you guessed +16, you were correct, because that's 2 times 8. So 2 goes to 16, that's 212, so I'm going to go just off my graph. Remember that this is continuous, so I want to kind of connect the dots as best I can. It's got this little snake shape. That's how it's going to look. All right, and that will conclude this set of notes. So hopefully this helps you with those non-linear ones. If you need to ask for more help on your specific problem, don't hesitate to do so. A good goal by the end of class on Friday is that you are finished with 4.1 and 4.2s Math Excel, or at least as close as you could be to that. Thanks for your time and have a nice day.